Hello guys, and welcome back to this tutorial. This is the sixth part of this series whereby we are building our mapping application using pgRouting, Geoserver and leafletjs. The end goal is to have an application whereby we can get the path between 2 points, so that if we are moving from point A to point B, we should be able to get the shortest path between those two. So last time you were able to create the to determine the costing mechanism, whereby we are going to use the Dijkistra algorithm. So in this case now we want to publish our data to Geoserver and then create the SQL views that we will use to run the routing functionalities. So the first thing that we want to do is to make sure that you are connected to your Geoserver instance. I'm using Ubuntu 16.04. so you can check out the link on the description to see on how you can install Geoserver in your local development environment. So I'm going to log in and then I should be able to see my dashboard. So the first thing is to create the workspace whereby we'll be working on. So I'm going to call it just routing, yeah, and then namespace, give it the same as the name, and then submit. The next step after making the workspace, so we will want to connect our PostGIS database that we had early created. So to do that, we need to create a store. So you come to here on the left hand side, the sidebar, you should be able to see these options. So if you click on stores, you should be able to see the option to add a store, and then you can see different sources for your data store. So the first thing or rather the thing that you want to connect to is to the data source is PostGIS. So we go ahead and select PostGIS, and then here you'll need to fill some info on how to connect to your PostGIS database. So the workspace we are using is routing, and then data source, you can also call it routing, description you can give it, but I'm just going to leave that. So here you have the connection parameters for your database. So my database, I know it's called rootdb, so make sure you give it the correct database. My username is Postgres, and then I'm going to put in your password. Yeah, basically that's the minimum information you need to get started. And yeah, there you should see the tables in your connected database. So basically that's how you connect your database to Geoserver. And now once we have this, we are ready to start adding views and working on this data, so that we are able to call these views from our front-end mapping application. So once you have your database connected, and you can see the table that we had made earlier. So if you see on the stores, you can see that the store has been created here. So the next thing we'll want to do is to make the tables to be layers that we can use in Geoserver. So to do that, you come to layer, then click on add layer. So you click layers and then add layer, and then you're going to choose the store, which is in our case is routing. And then we are more interested in these two tables, the edges noded that contains the nodes, and then the edges noded vertices that contains the vertices. So we'll be using this one to query the nodes, or rather the vertices of the application, so that we are able to get the nearest points that you are. So if you select A, we are going to query these nodes so that we know which nearest vertice are we going to use to query the data from the edges noded database. So this will be more clear once we start building the application. So we'll want to publish these two tables. So to do that, just hit publish, and then we need to fill in some information here. The most important one is the coordinate reference system. You can see, so make sure it's in this format. You input this SRID code, which is EPSD 4326. If it's not in this format, you can click on find and then you can search here. So if I put 4326, I should be able to see the WGS, geographic coordinate system. So make sure it's in both the native and the declared, both in that for the geographic. And then want to compute the bounding boxes, just click from data and then here from native bounds. Yeah, this should be okay. Once you do that, you hit save and then you do the same thing for, you repeat the process, but now publish the edges noded vertices. So you publish that and then repeat the same, make sure it's in this coordinate system and then compute from data, compute from native bounds and then publish. So if you see on the list of your layers in Geoserver, you should be able to see the edges noded down here and the edges noded vertices. So these are the layers that will be querying. But now another thing we'll want to do is to create custom SQL views that we'll use to query our database and then execute the custom logic of the Dijikistra algorithm so that we are able to run the query that we did previously on Geoserver. Geoserver has a concept of something called SQL Views. So basically SQL Views is a way to execute custom SQL directly on your tables. Traditionally, the way to connect to a database data is to create layers from tables the way we did. You see, we have layers from the edges noded and then we have a layer called edges noded vertices that is based on the tables, on the exact tables in our database. But now we'll want to execute some custom SQL. So Geoserver has this concept of SQL views, which is basically a layer, but now it's not directly connected to any database, or rather it's not directly connected to a table, but it enables you to execute custom SQL on these tables in each request to this custom layer. So this avoids the need to create database views from PostGIS to execute complex queries. So basically you have custom SQL running on each request to query your layer that is connected to your database tables. So in this application we'll want to have basically two SQL views, once for the shortest path and then the other for the nearest vertex. So when you come to the application, you will want to when you come to this app, the first thing that we'll do is to maybe if you can look at the SQL views first of all. So the first one that I've said is the nearest vertex, and then the other one is the shortest path. So what the nearest vertex should do, it should find the nearest vertex to any point of our data. So as I was saying, when you come to the map, you click say on point A. If you click on point A, say you click on point A, and then we should be able to send a request to Geoserver, our Geoserver backend, and then pick this location of where the user clicked and then compare this with the vertices that we add in our edges noded vertices table. So we are going to find which vertex is nearest to this point that the user clicked and then return this point and save it somewhere, and then click the second point, repeat the same procedure, pick the coordinates of where the user clicked from the map, send them to Geoserver, calculate which vertex is nearest to this point that the user clicked. Once we have these two vertices, so that's point A and point B, now the next thing is to use these points that we know are in our database. So say the first point was 0.9 and the second point that the user clicked, the nearest one was found to be 0.20. So we are going to just pick the numbers, or rather the IDs of these points that are in our noded vertices table. So say 0.9 that we have found from the user that clicked point A and it was sent to the to the database and came back as we are told that this point, the nearest point is 0.9. To point B, the nearest point is 0.20. So we are going to now package these 2 points and send them to this SQL view, the shortest path SQL view. So this is now going to run the Dijkistra algorithm and then give us the shortest path. So we are going to give it vertex 9 and vertex 10, and then it's going to use these nodes or the vertices to run the shortest path SQL function that we are going to write. So in a nutshell, those are the SQL views that we need. Next, now we'll be creating these SQL views. Another thing that we should know is that these SQL views will be receiving parameters. So the advantage of SQL views in Geoserver is that they can be parameterized. So in this case, we'll be giving it maybe point X, and then you can give it the SQL views can actually receive parameters. You see, they can receive the point that you want to check against the vertices in your database. The shortest path can receive the starting point and the end point. So these are the vertices that you are able to get from the nearest vertex. So yeah, so that's a point to note, is that these views are actually parameterized, and we are going to define these parameters from Geoserver. So I hope this idea of SQL views sticks, because it's actually the important thing that we'll be using. So that said, let's get to the next point, that will be now creating these SQL views on Geoserver.